A third example of trigonometric substitution. Suppose we want to integrate the square root of x squared minus 1. Now you're looking at that and you're thinking something squared minus 1 equaling something squared. How about we set x equals to the secant of theta? And that means that dx is secant of theta, tangent of theta d theta. So this whole thing becomes the integral of secant squared of theta minus 1 times secant of theta, tangent of theta d theta. Secant squared minus 1 is tangent squared, so we have the square root of tangent squared of theta times secant of theta, tangent of theta d theta. Square root of tangent squared is just tangent, so we are left with tangent times tangent, tangent squared of theta, secant of theta d theta. And now we look at this and we think, well, we can't set u equal to tangent because we'd need to have secant squared d theta, and we don't have that. We can't set u equal to secant because we need a secant tangent, not two tangents. The trick that we're going to do here is we're going to turn the tangent squared into secant squared theta minus 1 times secant of theta d theta. And this turns into the integral of secant cubed of theta, I'll split it up, minus the integral of secant of theta d theta. And oh, we've done both of these. We've done both of these. Only one of these do I have memorized, so just for the fun of it, I'm going to do it out again. This one we do with u substitution. U equals the secant of theta, dv equals secant squared of theta d theta, so that du is secant of theta, tangent of theta, and v is tangent of theta. So that first integral becomes secant theta, tangent theta, minus the integral of, what is this? Secant of theta, tangent squared of theta d theta, and minus the integral of secant, which of course we know now is the natural log of the absolute value of secant of theta plus tangent of theta plus c. We don't necessarily need the plus c, but we've got it. What do we have? If you look at it this way, you see that we have a minus secant of theta tangent squared equaling secant of theta tangent squared, so we can bring that to the other side and would have two of them, and we can divide by 2, and we will get the integral of secant of theta tangent squared of theta d theta is 1/2 of everything that's left. 1/2 of secant of theta tangent of theta minus the natural log absolute value of secant of theta plus tangent of theta. In absolute values, and I'll just put that c out front. Yay! And now we need to bring it all the way back into x's. Where was the last time we had x's? The last time we had x's when we set x equal to the secant of theta. So we have x is the secant of theta. What does that look like? It looks like a right triangle where this is theta. Secant is hypotenuse over adjacent because it's 1 over the cosine. So x over 1, this is square root of what? X squared minus 1. Right, when you square this and add 1, you get x squared. Right, that means that the tangent of theta is just square root of x squared minus 1. And so our final answer, because this thing, secant theta tangent squared of theta, was over here boxed in red, and equals what we want. So the integral of the square root of x squared minus 1 dx. Notice how the thing that we started with tends to pop up again when we do the triangle. That is not a coincidence. It's just called what we're integrating. Is 1/2. Secant of theta is just x. Tangent of theta is the square root of x squared minus 1 minus the natural log of the absolute value of x plus the square root of x squared minus 1 plus c. And if you want, you can take the derivative of that and see that it is the square root of x squared plus minus 1, but I believe it.